Hello there, Mr. Sutton here, bringing you this Algebra 2 10-2 homework solutions on degrees and radians. For the first couple problems, they want us to draw an angle in standard form with the measure that they're giving us here. So standard form means between 0 and 360 degrees, not including 360. So we have to either add or subtract 360 to some of these angles until we can get them to be in that range of numbers. So for 450, let me subtract 360 from that. That is going to be 90 degrees. So 90 degrees is just going to be this angle right here. To draw this angle of negative 10 degrees in standard position, we first have to get this to be a number between 0 and 360. I can do that legally by adding 360 to this. That's basically just going once around the circle. So that brings us to 350 degrees, which is right about here. On this problem, they want us to find one positive and one negative angle that are coterminal with the 70-degree angle here. So coterminal means basically it's the same position, but it's some multiple of 360 from where it started. So you can either add or subtract 360 as many times as you need to get as many coterminal angles as you want. If we want a positive coterminal angle, we can do 70 plus 360, which would give us 430 degrees. And if we need a negative one, we can do 70 minus 360, which would give us negative 290 degrees. For this problem, we're trying to find a negative and positive coterminal angle for negative 125. To get a positive version of this, we can add 360 to it. So that's going to give us 235 degrees. And to get a negative version, we can subtract 360. That will give us negative 495 degrees, or 85 degrees. For the next several problems, we're trying to convert things that are in radians to degrees and things that are in degrees back to radians. In this one, since we're starting in radians mode, which I know because there's no degree symbol, I have to multiply by 180 degrees over pi in order to get this into degrees. And let's do a little cross canceling now, because I have to do this without a calculator. So pi's are canceling, and then 180 divided by 4, we can reduce that to 45. So we have 3 times 45, which is going to be 135 degrees. To convert 40 degrees into radians, I'm going to multiply this by pi over 180 degrees. So 40 and 180 can cross-reduce here. Those are both divisible by 20. So 40 is going to become 2. 180 is going to become 9. So we then have 2 pi over 9 radians. To convert this one into degrees, because it's already in radians, I'll just multiply by 180 over pi. Doing a little cross-canceling, the pi's cancel. 180 and 3 can also cancel. That gives us 60. And we can also write a little 1 down here if we want. So we've got 5 times 60, which comes out to 300 degrees. To convert 225 degrees into radians, we're going to multiply by pi over 180. 225 and 180 are both reducible by 45. So we can make this 5 and 4. So then 5 pi over 4 is our final answer. To convert negative 260 degrees into radians, we're going to multiply it by pi over 180 degrees. 260 and 180, those are both reducible by 20, and I think that's as good as it gets. So that gives us a negative 13 up here, and down here this will be a 9. So negative 13 pi over 9 radians. For this problem, on the honors part of the problem set, we want the arc length and area of a sector that has a radius of 9 feet and a central angle of 60 degrees. So we've got our two formulas for arc length and sector area. Arc length, remember, we've got r times theta, the radius times the angle, assuming that you're already in radians. That is a little bit of an adjustment we have to make on this. So we've got our radius of 9, and then 60 degrees expressed in radians, because that's how this formula works, that is pi over 3. So then 9 pi over 3, or 3 pi, would give us our arc length. And that's going to be in feet because of the units they gave us there. Now for sector area, in general, the formula for that is 1/2, let's see, theta r squared, or r squared theta, however you want to write it. So this is 1/2 times 9 squared, times again pi over 3 for the angle. And then, let's see, 9 squared is 81. 81 divided by 3 is 27. And then we have a 2 in the denominator still. So this will be 27 pi over 2, and that'll be square feet. For this problem, we have the observation deck of a building that makes a sector with these dimensions shown here. So it's a 10 by 10, 90 degrees, and here's our safety rail. They want the length of the safety rail and the area of the deck, which are perfectly legitimate questions to ask about in terms of building things. So for the safety rail, we're asking for the arc length. The formula for that is going to be r theta, where r is this 10-yard radius, and theta is this angle, but we have to put it in radians because that's how this formula expects it to be. So 90 is really pi over 2 radians. And then 10 divided by 2 is 5, so this is 5 pi, and that's going to be in yards. Now for the area of the deck, we're going to have 1/2 r squared theta for that formula, because that's sector area formula. So 1/2 times 10 squared times, again, our angle of pi over 2. 10 squared is 100. We've got 100 divided by 2 and then divided by another 2, so divided by 4. So that's 25, and then we have a pi up there, and that's going to be 25 pi yards squared.